exists, and across into Victoria Land in East Antarctica. These volcanoes, some of them weren't discovered until a few decades ago. They are very seldom visited. Most of them have been visited once or twice in their whole histories. Very few people get to see them, so I'd like to show you a few of those before I continue, because they're worth seeing. They're generally very beautiful objects. Beginning in the South Sandwich Islands here, this is Saunders Island. It's quite a small island, about 8 kilometers across. The summit's about 1 kilometer above sea level. There's just the summit island, which rests on top of a large volcano under the sea. The volcano sits in water 2.5 kilometers deep, and it's 25 kilometers in basal diameter. Now, the main part of the island is dominated by this structure here, which is Mount Michael, seen in the background. It's a small stratovolcano. It's almost completely covered in snow and ice. And you can see what looks like a cloud effect at the summit there. In fact, that's steam coming from the summit crater here. The crater is only a few hundred meters across, and you can see the steam is actually very dense. Normally when volcanoes are simply passively degassing, the steam rises and dissipates very quickly. This steam is unusually dense, and when you watch this from any direction, it huffs and puffs, which is very unusual. And working with colleagues of mine, former colleagues of mine, the British Antarctic Survey and the US Geological Survey, we were able to prove using satellite imagery that there is in fact a lava lake within this crater. And this is a very highly expanded satellite image looking straight down the crater of Mount Michael. And at the bottom here, these 2 red dots, which I hope you can just make out, they're individually about 10 to 20 meters across, and they're 2 large bubbles of lava just bursting at the surface of the lava lake. They look rather like 2 demon's eyes looking out from the Earth's interior. Now we've bounced over to Marie Byrd Land, which is a very remote part, which is Mount Hampton. Mount Hampton is a dead volcano. It's about 10 million years old. The summit's about 3,300 meters at its top, and has a diameter of about 15 kilometers above the ice. And it sits in ice which is 2.5 kilometers thick. The top is very flat, as you can see here. That's because it's a caldera structure. Now, calderas are the opposite of craters. Craters are generally up to about 2 kilometers in diameter. This particular example here is 6 kilometers in diameter and formed by a collapse. Calderas form usually after a climactic eruption, when the top of the volcano is destabilized and it collapses in on itself, and it leaves a great hole known as the caldera. In this instance here, it's now filled completely by snow and ice. This is Mount Berlin, also in Marie Byrd Land. This is an active volcano. The summit is about 3.5 kilometers up. The diameter is 20 kilometers. There's no caldera here, just a small crater. It's been a very active volcano in the last several 100,000 years because ashes, which can be compositionally linked to this volcano, have been found in numerous ice cores taken in the region. Similarly, this is Mount Takahe, which has also been very active the last few 100,000 years. Although neither Takahe nor Berlin have been observed in eruption, we know it has erupted because of these ashes in the ice. It's a very big volcano, much bigger than Mount Berlin. It's about 35 kilometers across above the ice. It has a large summit caldera, about 9 kilometers in diameter, completely filled with snow and ice. Then we've got Mount Erebus. I suspect that if you didn't know there were many volcanoes in Antarctica, if you were asked to choose an Antarctic volcano, this is probably the one you'd come up with because of its historical associations with Scott and Shackleton. It's an active volcano. It's the largest volcano in Antarctica. It has a basal diameter of some 40 kilometers and the summit just less than 4 kilometers. Absolutely enormous volcano. And you can probably notice that it has prominent shoulders up here. That's because this volcano also has a summit caldera, this collapsed structure, which is about 6 kilometers across. But unlike the previous volcanoes I showed you, this volcano continued erupting after the caldera collapsed. And the caldera, this Great Depression, was filled by lava. It became brim full, and some of the lavas have spilled over the edge and have flowed down the left-hand side, as you can see here. The volcano continued building its top, and you can just see the summit of a central cone. And ultimately, the volcano will completely rebuild its top. You can just see a small part of that summit cone. And here's a view of the crater on that summit cone, and right down on the base of this crater here is another lava lake. And this is a permanent lava lake. It has been in existence for the last 100 years and probably for many hundreds of years. And Antarctica is unique in terms of regions of the world in that it has 2 volcanoes with permanent or semi-permanent lava lakes. Now moving into East Antarctica, into Victoria Land, this is Mount Overlord. Mount Overlord is a dead volcano, even though it looks very well preserved. It's about 7 million years old. The summit's about 3,500 meters above sea level, has a basal diameter of about 16 kilometers, so it's a kind of moderate-sized or middling-sized volcano. Also in Victoria Land, we have Mount Melbourne, rather nice volcano. We call it a stratocone because it has quite steep slopes and is a perfect cone shape. The summit's 2,700 meters, basal diameter 15 kilometers, so about the same size as Mount Overlord, but no caldera, just a small crater. And we know it's active because if you go to the coastal cliffs, we find ash layers in the ice which match compositionally with ash on the volcano seen in the background here. And this particular ash layer in this ice cliff I'm showing is about 150 years old. Although it's not been observed in eruption, it clearly has the potential to erupt again. And before I go away from this photograph, in the foreground is another volcano, this long peninsula in the foreground here. It's been extensively eroded by ice and by the sea, and this is part of a 2-million-year-old shield volcano. It's called a shield volcano because the slopes are very much more gentle compared to the stratocone of Mount Melbourne behind. You might be curious to know when the last volcanic eruption in Antarctica took place, and the answer is between 2001 and 2007 in the South Sandwich Islands on Montague Island. Here's a view of Montague Island. It's about 12 kilometers across with a big caldera, 7 kilometers in diameter, full of snow and ice. And in the center we have another cone, rather like Mount Erebus, but not so well developed. And the crater you can see in this is absolutely brim full of lava. The lava is pouring out the north side here, and it's carved a deep channel right across the ice field to the north coast, where it's tumbled down the very steep slope there into the sea. And where it met the sea, it formed new land. And you can see these lobate features are the new land which this volcano has formed. And here's a view of that lava coming down the north coast here and plunging into the sea and creating the land. And here's a view of the front of that lava flow. It's about 50 meters high and it sits in water about 20 meters deep. But you might wonder, why is it that volcanoes are able to tell us about ice sheets? And I'll try and answer that as simply as I can. Now, all of us, we don't have to be earth scientists to know that volcanoes are very capable of causing substantial devastation of the environment, not just on local or regional scales, but occasionally on hemispherical scales. For example, I suspect most of us have heard of supervolcanoes. They can affect whole hemispheres, although most volcanoes don't. But most volcanoes cause immediate impact, at least on local, if not regional scales. And about 20 years ago, I asked the same